Hello friends, my name is Tejan Jangir. Here I am discussing the solution of Assistant Executive Engineer previous year paper, and next video is coming soon for the solution of this paper. And coming soon solutions are previous year paper of engineering examination and power electronics, P.S.Bimbhra, EMFT Matthew and OSIDQ, electromagnetic SOMS outline series, signal system SOMS outline series, and many more. So don't forget to subscribe my channel, that is anybody can download education like at ABCD education. Okay, now come to the question number 85. The first row of route tabulation of the third order system are shown, are as follows. Okay, so come to the solution. Now these element of route tabulation which are equal to each other, so this element becomes zero. So due to this, uh, here auxiliary equation is like, so the auxiliary equation equals to 2s square plus 2. So by differentiating the auxiliary equation we get the this element which is equals to 4, by differentiating the auxiliary equation, and last element of route tabulation, that is 2. Okay, so if the no sign change below the auxiliary equation, then the roots are symmetrical about the real axis. So so the roots are s equals to plus minus j. Okay, and one root is lie in the left half of s plane. Okay, so the answer is third. So the roots are plus minus j and one root lie in the left half of s plane. Okay, so the correct option is third. Now come to the question number 86. Which one of the following variable cannot be taken as a state variable? For the state variable we use integrator and differentiator. So in the current passing through the inductor, I equals to uh, v equals to L di by dt. So it is differentiate, so that it can be used as a state variable where I can be used as a state variable voltage across the capacitor. Okay, so the I equals to dvc cdv upon dt. So the voltage can also use as a state variable because it is differentiator and output of integrator, which is also used because it is integrator. Okay, so but current passing through the resistor, that is the linear equation which is equal to v equals to ir, so it cannot be taken as a state variable. So the correct option is third. Now come to the question number 87. Which one of the following compensator is used to increase the speed of the response? Okay, so the lead compensator is used to increase the speed of the response. Why? Because we use lead compensator, then the phase margin of the system is increased. Due to this, stability of the system is increased. If the stability is increased, then the gain of the system is decreased. Due to the decreasing in the gain, then the bandwidth of the system uh, is increased. If the bandwidth is increased, then the rise time will decrease. If the rise time, delay time, and peak time, both of three are all of three are decreased, then the uh, total response is becomes very faster because the time is decreased. Okay, so the increase the response when increase the speed of response when we use lead compensator. So the correct option is 1. Now come to the question number 88. Which one of the following is not true? Okay, so come to the solution. We know that state model is can be formed by the help of many method. Okay, that is conical method, cascaded method, differential equation method. Okay, so there are different method, or which produce the different state model. Okay, so the state model is not unique, so the answer first, option first is not true. So the correct option is first. Now come to the question number 89. The initial slope of the board plot gives an indication of type of a system, stability of the system, nature of the time of the response, and the gain margin. Okay, so the initial slope at the frequency omega equals to 0, it gives the pole at origin. Okay, So which is indicate the initial slope of the system, which is also indicate the type of the system. So the answer is correct. Answer is first is correct. Okay, so the correct option is first. Now come to the question number 90. A rough measure of bandwidth of the system is, bandwidth of the system is, the bandwidth of the system is live when the magnitude of the system is unity, and where the magnitude of the system is unity, uh, then the frequency of the system is gain crossover frequency. Okay, so the correct option is 2. Now come to the question number 91. A meter has the full scale angle of 90 degree at a current of 1 ampere. This meter has the perfect square law response. Square law response. It means theta equals to I square. Okay. Assuming the spring control, the current for a deflection angle 45 degree will be. Now come to the question number. Now come to the solution. We know that it is the square law response, so theta is directly proportional to the I square. Okay, so if angle is reduced by half, then current will get 1 by root 3, so it becomes 0.707 ampere. So the correct option is third. Now come to the question number 92. Two ammeter, one will full scale current of 1 milliampere and internal resistance of 100 ohm, and other with full scale current of 10 milliampere and internal resistance of 25 milliampere are connected in parallel. Okay, when what is the total current these are what is the total current these two meter can carry without meter any meter reading out of scale. Okay, now come to the solution. These are the meter which are connected in parallel to each others. Then it can read the 1 milliampere and can read the 10 milliampere. Okay, which carry the I1 ampere and I2 ampere. Okay, so the resistance are these. Okay, so I1 equals to 25I by the current division rule. Then we get I equals to I1 equals to I by 5 and I2 equals to 4I by 5. Okay, so even maximum current can flow from the meter 1, that is 1 ampere. Then the I equals to 5 milliampere, then we get I2 equals to 4 milliampere. Okay, it equals to 4 milliampere. By putting the I 5 milliampere in this equation, okay, we get I2 equals to 4 milliampere. So the I2 and I2 are not out of scale though, so it can permit in the meter. But if we go from this equation, then I2 equals to 4I by 4, and then it is maximum value permit from this meter is the 10 milliampere. Then we get I equals to 12.5 milliampere. If this value is put in this equation, then we get I1 equals to 5 milliampere. This I1 value cannot be permitted because maximum value is 1 milliampere. So the I1 equals to I1 and I2 are I1 and I2 are 1 milliampere in this case, and I2 equals to 4 milliampere. These are permit. So the answer is 5 milliampere. Answer correct option is 4. Now come to the question number 93. The resistance of the circuit is found by measuring the current flowing and the power fed into the circuit. If the limiting error in the measurement in the power and current are plus minus 1.5% and plus minus 1% respectively, the limiting error in the measurement of the resistance will be. Now come to the solution. According to the question, we know that R equals to P upon I square. Okay, now taking taking the logarithm of this equation, then we get ln R equals to ln P minus 2 ln I. Okay, now after differentiating this equation, we get limiting error dr upon R dp upon P minus 2 di upon I. Okay, now put the values of this limiting error which are mentioned in the question, then we get dr upon R, that is limiting error, we get at 3.5%. So the correct option is 4. Now come to the question number 94. Error due to the change in the frequency in moving iron instrument is reduced by connecting a capacitor C across the series resistance R if L is the inductance of the coil, and the reading of the instrument will be independent of the frequency only when these are options. Now come to the solution.